Hello, 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 everyone. How's it going? Long time no see. I think I've been out of streaming for like 2 months. I missed two global hack weeks, if I remember it correctly. The first one I was out on holiday. The second one I was very sick. I was down with flu and stuff, so yeah, couldn't do it. So it's good to be back. How's everyone doing so far? How's Global Hack Week been so far? I think you just had build mini AI assistants with APIs with Vincent. I hope that went well, and I hope you all learned something new from there. Okay, for folks who are just joining, please do check in slash register for the event. The link is in the chat, but I can just share it again with you all. Let me quickly do that. Okay, there we go. Please do check in. Please do register. I can't stress on it enough. And okay, so first of all, welcome everyone. We are going to have a four-part session on hosting website on ESP-32. This is part one. Uh, a few notes before we get started. And actually, before I give the notes, let me quickly introduce myself. My name is Kash, but I prefer to go by UT. That's how everyone knows me in MLH. So yeah, you can just tag me as UT on the Discord chat, or you can just ping here if you have any questions at any point. I am a coach and I also love to stream. I think I used to keep account, but since since I missed out on last 2 months of streaming, I have lost count. So I'll get back to that. I'll go and check how many streams I've done so far. Uh, Close to about 70 or 80, I guess. So yeah, that's about me. I am going to take these ESP-32 sessions. In the previous Global Hack Weeks, my interest slash what I have tried to do is run these workshops where you can basically follow along. Now, this would be, I think, the first time where I would be running a workshop, but most of you would not be able to follow along. Uh, and the reason why is I'm assuming that most of you don't have a ESP-32 lying around in your house. Now, folks who are very confused, what is ESP-32? What is he talking about? I will let you know, okay, as this progresses. A few notes before about the four-part sessions. Uh, so, first of all, I have two sessions back to back today. So I have this current session part one, which will be for 2 hours, and then right after that, I'll have part two of this session. And you may be like, "Oh my God, 4 hours of listening to this guy." Don't worry, I will give you a break in between, a 10-15 minutes break, so that you have just time to relax, have some water, eat something, and then you can come back. The second thing is that, as I said, most of you might not have a ESP-32 lying around in your house. So that is fine. You can still kind of look at what I'm doing, how I did it, and why I got interested into this whole project. So you can do that. And whenever you do buy one, I guess you can just come back and uh, refer to these sessions, right? So that is the second thing. The third thing is that this will be a very beginner level workshop. So then all four parts are going to be beginner level. The only expectation I have is, or the only prerequisite, I would say, I have a lot of expectations from you all, but the prerequisite is you need to know some part of coding. Python is preferable, of course, but it is okay if you don't know that. Some bits and pieces of coding would be highly appreciated, because I don't want to spend too much time explaining bits of, okay, what is this program doing. I want to show you what it is doing and just, mess around with it. So that would be really helpful if you know some bits and pieces of, like, you're not a very beginner into coding, but that's okay. You can still follow along. I try to ensure that I explain everything that I'm writing. And at any point, if we are stuck, you are stuck, I am stuck, we can always use one of the very, I'd say, one of the intelligent LLM models that we have access to, right? So yeah, we'll do that. And yeah, and at any point you have any questions, please feel free to put them in the chat. I'll try to answer them as soon as I check the questions. Cool. Uh, any questions so far based on what I've said? Uh, Let me look at the chat. Hello. Once again, if you have not registered, let me start by just quickly sharing the registration link. Okay, so I hope that has been helpful information so far about what the sessions are going to be, and what are we doing, what are things we are going to. I haven't actually talked about what are we going to cover. So the idea that I have for these 4 sessions, as from the title you must have understood, that we are going to host a website on ESP32. But since I said it's a beginner level session, we'll start by actually understanding what is ESP32. So the first, I would say, next 1 hour would be very theoretical. I'll be just talking and talking and talking. Uh, but hopefully you will have some interesting questions for me. Then the next hour we'll try and set up ESP32. So I will tell you the installation guide that I followed, and at any point we want to have access to the code, I will have it. Okay, I will try and ensure that you have access to the code that I am writing. I will push it on GitHub. I'll also try and push all the installation guides that I have on GitHub. So I'll tell you how I installed it. For Mac, you can follow the same thing. So for Linux/Mac OS, you can follow the exact thing that I did. But for Windows, there might be some commands which will be different, but that should be fine. So like you can always Google that bit, or if I have it in my notes, I can share that. Okay. So that would be the next bit. So we'll try and communicate with ESP32. So first learn what it is, then communicate with it. Then the next session, which is right after, we will try to see if we can write some bits and pieces of code which will allow us to connect to Wi-Fi, scan for Wi-Fi networks, connect to it with ID password. We'll try to create our own web server. So we will try to control ESP32 via a web page which would be running on our system. And if the time permits, I will also host it so that you all can connect to my ESP32, which is running on my like here in London. Okay. So we'll Yeah, those are the things that I want to cover in the first 2 sessions. And yeah, I think that should be it. Frankly, I guess like by the time we finish all of this, we would have reached the end of part 2. And part 3 and part 4, there the idea that I have is I want to build this very interesting, very simple project. The project idea is not unique, and it is certainly not my own. I actually got that idea when I was clearing my bookmarks. So I saw that uh, I had a bookmark, which is this one, uh, hosting a website on ESP32 web server. So I wanted to do this project in the last Global Hack Week. Excuse me. So I wanted to do this in the last Global Hack Week, but I was out sick, so couldn't do it. Now that I'm better, I'm doing it at API Week. Otherwise, this would have been a very good project for the Open Source Week, as I was planning it originally. I have shared the link to this uh, blog in the chat. So not a unique, I would say, what's the word, it's not a unique project idea that I have, and it has definitely been done before. And I actually got it from, I got the idea from this blog which I had saved once upon a time in my bookmarks. And I was like, oh, this looks cool, can I try it on my own? And I wanted to enhance it a bit. So yeah, you can take a look at this. We'll try to replicate kind of this bit, like this project. But what I want to build is a portfolio website, kind of hosted on ESP32. So you can leave your ESP32 up and running. Depending on the country you are in, electricity is either cheap or costly. uh, I would say in the UK it is somewhere in between. It's not very cheap, but it's also not very costly. uh, in India, I would say comparatively it is cheaper. So that is a good thing. So you can definitely keep it running 24/7 if you're around, if you're joining from India, if you're trying this project out in India. I know that because I'm from India. Okay, so yeah, we'll have a personal portfolio website that we will keep up and running. And if the time permits, then I'll also try and create kind of a structure where any one of you can raise a pull request in to have a portfolio website, or to have your details in a certain format. And periodically I can pull that and put it on ESP32, and you all can basically look your details, your portfolio website, or running on my ESP32 web server, I would say. So this is kind of the idea that I want to build slash show you all how to build. And the second bit, the last bit that I said, that where you all can do it, that may not get covered in the 4-part session. But if you've watched my previous streams, then you know that my GitHub is always open. People do send pull requests, so you can always uh, keep an eye on my GitHub account. You can keep an eye on this GitHub project, this GitHub repository, and I will update the README telling when you all can actually put something, or do all the extra bits. Okay, so I guess that's good enough intro for everything that I wanted to talk about. Now, let's start with this. Let's start with the session. Okay, so there is one question already. Is it like Nginx? When you say so, I would say yes, kind of like Nginx, but Nginx would actually be more or less only for static files. Like, it is good for static file serving, but we in this case we'll have actually technically static and dynamic file serving. So we'll be using Python for this, which is why I think initially I said some knowledge of Python would be really good. And this is no, part 1 and part 2 is today. Part 3 and part 4 is tomorrow. And don't worry, you'll have like 1 hour gap between part 3 and part 4, but not only 15 minutes break between part 1 and part 2. But anyways, all the sessions are recorded, they are on YouTube, so it is okay if you're missing out. You can always go to the Major League Hacking YouTube channel and watch all the Global Hack Week live streams there. Okay, cool. Okay, so first of all, like, let's start with the very beginning. What is ESP32? And what am I even talking about when I keep saying, oh, ESP32, web server, web framework, blah, blah, blah? Okay, so ESP32, let me start by talking about what is ESP32. We'll talk about bits and pieces of, what it is, how it works, stuff like that. And let me get my notes open so that I don't mess on any words. Uh, First of all, this, if you can see it on the screen, and also let me just zoom in. Okay, I think this should be visible. Yep. So this is ESP-32. Normally I have backgrounds on my stream behind me, but I knew that, well, I'll have to show this again and again, so might as well, keep this, keep my background off. So this is ESP-32. It is connected with a C-type cable, and it is connected to my Mac. And what it is a microcontroller. Okay, what is microcontroller, you ask? I hope you ask. Okay, so it's a small, low-cost microcontroller made by Espressif Systems. Microcontroller is, think of it as a piece of hardware which you can programmatically control. Okay, a very uh, offhanded description of what is a microcontroller, but I think it makes sense. It is a piece of programmable hardware. Okay, and it allows you to do a lot of things via uh, a lot of inbuilt ch- uh, functionalities in the chip. Okay, so this one, let me zoom in again for someone who missed it and just joined. So this one, it has built in a Wi-Fi. Like, that is one of the features. It also has a lot of other things, but it has built in Wi-Fi, which means, and Bluetooth, depending on which one you buy. So you'll have this one, I think has Bluetooth, though I haven't tried it out yet. You'll have built-in Wi-Fi, which means you can connect to your own Wi-Fi via like mobile hotspot Wi-Fi, or your any Wi-Fi device, a router that you have at your home. Okay, it has uh, a processing power, so it is technically has a central processing unit, your CPU. It has a lot of GPIO pins. If GPIO means general purpose input output, and what that allows you to do is you can use it to connect to certain sensors. You can use it to connect to uh, motors, LED lights, uh, and a lot of, I would say, a ton of sensors that are available out in the market. So if I quickly have to Google like sensors to connect with ESP-32, like list of sensors, I should see a lot, but let's quickly have a look. Humidity sensor, like I needed some names. Humidity sensor, you can attach a camera module, you can attach temperature sensor, you can attach LED with potentiometer, which will allow you to control how bright should it basically light or burn, how bright should it burn, motion sensor to detect motion, uh, and yeah, a bunch of things. Now ESP-32 is not the only microcontroller you have. You may have uh, heard of possibly Arduino, which is, I think, the most uh, commonly known slash very popular piece of microcontroller device that is out there. uh, it's a full-fledged system in a way. Okay, it's a full-fledged CPU, which allows you to connect to screens like LCD screens. It allows you to connect to keyboard, mouse. Okay, make a normal proper laptop out of it. And not just Arduino, another popular one is Raspberry Pi. So these are other microcontrollers that exist. Now, I have chosen the cheapest one, which will allow me to have access to Wi Fi, because I want to build a web server out of it, which means that I want to keep it up and running, connected to the network, to the internet. Uh, this one cost me like £1 20, I guess. Uh, yeah, £1 20 pence, I think, which is like $1.50 or 60 cents possibly, or in INR it would be around 200 rupees, 200 INR. So this is the cheapest one that I could find. Bought it from, I don't remember, I think AliExpress. Okay, So yeah, this is the cheapest module that I could find, and I got it from there. No, not from AliExpress. I don't think I bought this one from AliExpress. I think from a local hardware. Yeah, this one was from a local hardware shop. Uh, okay, where they were selling microcontrollers. And now, the idea is, as I said, it is programmable, which means you can actually plug it in your computer via USB, which is exactly what I'm doing. And you can write code, and you can then install that code or kind of run that code on that particular microcontroller system. Now, there is a question: can we also install in it like drivers? Yes. uh, in this case, the drivers would be, let's say, if I want to run Python code in MicroPython, then I would install Python library. I could technically also install a bunch of other things, but they are not really needed. uh, since the whole thing is very programmable, which means it comes installed with the support of all the major things that you would need it to do. Okay. Example: sending a signal, receiving a signal via the general purpose input output pins, providing it a power, using power from the ESP32 to kind of run your sensors. Okay, so all of those things are available. Now, I made a very quick diagram. Actually, that's a lie. I didn't make it. I searched for a photo. I couldn't find one. Couldn't find a nicer photo which would be very minimalistic of what I have. So I asked ChatGPT to create this one, and I think it did a pretty good job. It took a few iterations. Like, I wanted it to have exactly the same pins that I have on my board. So it took a few iterations, but I finally had everything that that is needed. So I'm going to basically go away from screen, give you the access to the whole of this PPT so that you can focus totally on that. The reason why is I want to give you kind of a theoretical overview of all these pins that are available on ESP32. Actually, before I do that, let me come back on screen. So when I say pins, hope it is clearly visible, but you see, like, there are things written on this. Let's see. Okay, yep, there we go. uh, GND, D13, D12, D14, and if I go down there, 3V3, D15. So these are pins, and I can actually remove it from this protective covering, and there we go. So these are the pins. So these pins can be connected via a breadboard. So if you are an electronic student, you know what is a breadboard. But if you're not, let me quickly do a Google search and show it to you. uh, there we go. Perfect. I can open one of the images. So breadboard is basically, it's called breadboard. It looks like bread because it has those holes in it. But what it allows you to do is you can take those pins that you just saw, insert it in the breadboard, and now you have access to a lot of these points from which you can pick out wires and you can connect stuff. Now, in this scenario, what the user has done is they have connected a power supply, this black cable, into the ESP32 microcontroller module to give ESP32 a power. And then they have connected some pins to light up this LED. Okay. So they have chosen like this particular pin. Okay. In this particular column, if you see this gray wire, that is the negative or the neutral, negative, not neutral, negative to the LED. And then they have chosen this pin which is on this column, okay, right here. And they have kind of taken this purple wire, put it up here, added a resistor to kind of resist a lot of voltage flow, okay, reduce the voltage flow, like how, like assume like if this is giving out 5 volt of, uh, I'm going to use the wrong terminology here, but just to make you understand, for people who are not from hardware background, uh, it is if this is giving out 5 voltage of power, wrong terminology, then I use something called as a resistor to resist it out or reduce it by certain amount. Uh, so let's say if I want to resist it by 1%, okay, I can add a resistor which would, which is then connected to the other edge of this led. And led has 2 pins, okay, one negative, one positive. So the negative is connected directly, in this case the positive is connected via resistor to resist the, like, too much voltage coming in, too much current coming in, and then it lights up the led. Okay, led pins. Okay, this is to show you like led pins. So there's something called as the positive or the anode pin, and there's this negative or the cathode pin. So anode pin connected right here, negative connected right here, and this is kind of a parallel. Okay, so this line works row wise. Oof, that's reminds me of my engineering days. But okay, so that is basically what you use a breadboard for. You get access to these pins, and then you can connect wires and do stuff. uh, Now these pins, yes, there is this very right like question right here, which is every pin's significance is different. Yes, it is. So that is what I'm going to talk about. So what are these pins? What do they do? Okay, which is why the whole theoretical aspect. I can move away so that you can focus solely on this. Okay, good. So first of all, let's talk about the power pins. Okay, which provide power or like give power to connected components. So you can use these pins to give power to your ESP32 module. Uh, I may not completely say ESP32 every time. I'll say ESP, but you understand, okay? Like I'm talking about the ESP32. So the first one is this 3v3. So this means it provides a 3.3 voltage output. Okay, so you can use this as the plus part. Okay, the plus that you saw in the LED. So you can actually, can I copy this? Copy image. I'm back on here and let me paste it. Okay, all image, like this image belongs to their respective owners, copyright owners. Cool. So the 3v3 bit, which is 3.3 voltage output, you can use it to give this plus bit power, 3.3 volt of power. Okay, then you have this v in or vn pin, which is 5 voltage of input. Okay, sorry, this one, v in, it gives you this 5 voltage of input. So this was output, this is input. So you can use it to give power to ESP32 itself if you have not connected the USB, uh, which I have right now. And then you have this GND, which is ground, which is kind of your negative or the common reference point for all circuits. Okay, so that is your GND or ground pin. So that goes into your this minus, let's say, like you can do that. uh okay, so that is about it. Nothing else would be for the bar itself. Cool. Next one is the GPIO pins, or the general purpose input output pins. Okay, now general purpose input output pins, why is it called general purpose? If you have that question, the reason is that you can use it for a lot of things, right? Like literally general purpose. It starts from, there must be, I don't see it. Okay, not in this diagram. But you have technically like D0 or GPIO 0 up until D33 or GPIO 33. So 33 pins. Uh, the D0 or the GPIO 0, it's an input output. It is used to enter the boot mode when you want to flash your ESP32. Now, I have used some terms. Boot mode or flashing, think of it as erasing everything that ESP32 system knows and installing a new software. Okay, so if you flash your laptop, or you enter the boot mode, and you flash out your laptop, it's like you are uninstalling Windows or Mac OS from your system, and then you are reinstalling it. Okay. Then there is a D2 on the ESP32, which is an inbuilt LED. So we will actually mess around slash play around with that built-in LED. On my system, it is blue in color. Then you have some input output pins for like D4, D5, D12, 13, 14, like 12 to 19, I think 21 to 23, 25 to 27. Like these are all normal general purpose input output pins. And those are the ones that you use to connect to like things like LED, things like motors, things like other sensors, all those things. You'll use these pins. Then you have 32, 33, I think. These two are special. They allow for input, output, and analog. Okay, so analog sensors. What are analog sensors? Or what is analog itself? So things can be digital or analog. Let me come back on screen for this one. So things like think of it as a data. Okay, data can be analog or digital. Now analog is digital is 1 and 0. Okay, so either you have voltage or you don't have voltage, you have power, you don't have power, you have switched it on or it is off. That is your digital. Okay, 1 0, on off. Either it's there or it's not there. That would be a digital system. An analog system can be like, think of it, okay, as it is not there, so it is 0, but then it is there, like it is at 1%. So it's there but slightly, then it is there but more than slightly, so 1% to, let's say, 10%. Then it is there but more than 10%, like it's there but even more slightly, let's say. So it's like, it's not exactly 0 or 1, it has levels in between. Okay, smaller steps. uh, so if you know about analog waveforms like sine wave, there is something called sine wave, there's something like cos wave. So, or let's not go into that. Think of it as, okay, I, again, wrong example, but if this helps you visualize it, think if you are controlling the brightness of a LED, okay, or a bulb. If you're controlling the brightness of bulb, it is completely off to 100%, which is full power, and everything in between. So from off you go to slightly on, then more, then more, then more, up until you reach the 100% or the complete brightness. That whole thing would be called as analog. Okay, that whole kind of idea would be analog, which means it is not exactly 0 or 1, it has a lot of stages in between. Okay, so things can be digital or things can be analog. So where you can get analog signals from, you can get analog signals like from sensors like light sensor. Okay, or yeah, a light sensor, where you want to know if, for example, you're building a project where you want to water the plants early in the morning, or like, let's say, exactly at afternoon for some reason. You want to water the plants in the afternoon, exactly in the afternoon, and right before it is evening. So you are going to get a sensor which can sense light. Okay, and then you are going to configure it in such a way where you will say that if the brightness of the light around you is, let's say, at 100%, that's when you will water the plants. And if it is at like 40%, that's when you will water the plants, and you can ignore everything in between. Okay, so light itself is not 0 or 1. It's not like there is sun and there's no sun. There are phases in between. So you can think of it as analog signal. So from zero brightness to slowly and coming up, and like, it's getting brighter, 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 full brightness, and it starts reducing down, down, down. So that would be an analog signal. Okay. Wow, talking about sun for so long. Cool. There's a question. Hi, I just joined. What are we covering? So we are covering ESP-32. I'm doing the theoretical bits technically, which is talking about what are different pins on ESP-32. What is, like, we talked about what is ESP-32. We had discussion no, not a discussion. I was talking about what we are expecting from the next 4 sessions of this, uh, hosting a website on ESP-32 and bits and pieces in between. So it is okay if you don't have a ESP-32, you can still join the session, and we will be writing some Python codes. Hopefully that helps. Cool. Okay, so coming back. So then we have some pins, like, which are input only pins. They cannot be used to control outputs, cannot have outputs. So input only pins are also there on the system. Then you have pins with special usage. Okay, so there are some pins on this system which have some special usage. Now actually you won't be able to see it there, but I think I can show you on the video. So there is example a button right. Okay, where is my finger? Okay, there's a button right here, and there's a button right here. So one of them would allow me, like, I think it's the one on the right. Yep, the boot pin. Okay, so that will basically allow me to think of it as rebooting the whole uh, system. Okay, so if I do that boot mode, if I'm in the boot mode, it is, think of it as a programming mode, where if I hold it uh, while uploading code to my system, it will kind of reset the whole thing. There is also an en pin. It is on the left hand side. Let me show it again. So wait, which is my right? So this, can I, so you see en and you see boot. Okay, so the boot mode, it's going to kind of reboot your ESP-32. You can use it while uploading code to ESP-32. You can flash with it. And there is en, which is a reset. Okay, enable or reset. So it's going to restart ESP-32. Then there are some GPIO pins which are, where did it go? Come on. Okay, can't find it. But there are GPIO 6 to 11, I think. These are flash memory pins. They are used for Wi-Fi memory. So that has the code, or it comes installed with something which allows it to communicate with Wi-Fi. And GPIO 12 is a boot mode select or boot configuration. Okay, cool. So that's some of the major pins. GPIO, which is general purpose input output. Not every pin that you have on ESP-32 is, whoops, that is too big. Okay, cool. So not every pin that you have on ESP-32 is a general purpose input output pin. Some of them are, and these ones allow you to connect with sensors. Then you have some which allow you to kind of enable or reset or restart ESP-32. Then you have some which have some pre-built code, and if you're touching them or if you're messing with them, you could technically corrupt your ESP32 itself, and it won't connect to Wi-Fi, for example, anymore. But then you can also fix it using those pins. Then the two other major things that I want to talk about is communication. uh, okay, so that is one important bit, like how does communication happen. And then finally, uh, I think that's actually it. So in communication, we'll talk about a few things. Okay, so first of all, let's start by the most important or the easiest one to talk about. It is UART, communication. Think of it as, so what is communication? So in when I say communication, I mean that ESP32 also needs to talk to sensors, okay, or you can tell it to talk to other ESP32s, right? And there are various ways to do it. One of them is UART, or a serial communication. So excuse me. So UART, uh, you can use it for sending text data back and forth. Example, when I have connected it with my computer, with my laptop, with my Mac, then when I have to send or upload the code to ESP32, or I have to send the like get the logs from ESP32 over to my system, I can use this UART pin. In our case, I'm using it via USB directly, but you could do multiple things. Like you could kind of, like, that is one example, but you can use UART for other sorts of communication with, like, example, GPS sensors. Okay, if you want to add GPS sensor which is available in the market, then you can connect it and communicate with that GPS sensor using UART. Then you have SPI, or serial peripheral interface. That's also another way of communication. You can use it to communicate with, let's say, OLED display or SD card modules. Okay, and it allows different, like, you have four signals that you send when you talk about SPI. There is, or four pins. Okay, let's think about it that way. There are four pins that you will need for SPI communication. One is the data in pin, one is the data out pin, one is the clock pin, and one is the chip select pin. Okay, what do these mean? So data in means that it can receive the data. So it, in this case, is ESP32. So the sensor can send the data to ESP32 on this particular pin. Data out means ESP32 can send the communication or data to the sensor. Okay, so it is, so the incoming message come on one pin, the outgoing message are on another pin. Then you have something called as clock, or SCK. So this is a synchronization signal. It is used to, like, think of synchronization as setting the same time on the ESP32 as well as the other device that you're talking to. Excuse me. Okay, so that is a synchronization signal, as I was saying, that think of it as setting the same time zone and the same time on the two machines that are talking to each other, so that if it is 9 a.m. on ESP32, it should also be 9 a.m. on the device I'm communicating, so that if we have some sort of timing going on, that every hour we need to send each other hi, then the time should match, right? uh, think of it that ways. And finally, a chip select, which is if you have multiple devices connected, then which device should I send the hi message to is decided by this chip select, or CS in pin. Okay, so this is called as serial peripheral interface, or SPI communication. Again, you can use it for high speed communication with OLED displays, SD card modules, These are only two things that come to my mind, frankly. Then you have I2C communication, which is for sensors and, like, let's say, slow devices. Okay. This is inter-integrated circuit. I2C is inter-integrated circuit. What this means is that inter-integrated, which means you can have multiple devices on the same wire. Okay, so imagine two wires coming out of, like, these, like, two of the pins. I think it is 21, yeah, D21 and 22, I think. Yep, like these one. So D21 and D22. So imagine like two wires coming out of these two pins, and you have connected like temperature sensor, accelerometer, and whatever, like humidity sensor, two or three sensors connected to only like these two pins. So what would happen now is that you can basically say that, hey, uh, there are multiple sensors connected to these two wires, and when I receive the data which is in this format, it is from temperature sensor. When I receive data in this particular format, it is from accelerometer. Okay, how fast or slow you're going, acceleration, measure your acceleration. If it is coming from this sensor in this format, it is humidity sensor. Okay, so yeah, you can communicate with multiple devices on the same two wires. Okay, using I2C communication. And I think the final one that I want to talk about is PWM, pulse width modulation. So pulse width modulation, remember the whole talk I gave about analog and digital, and it allows, like, you can control the brightness of a bulb or LED, or you can control the speed of a motor, for example, using this, which is called as pulse width modulation. What you say is that, hey, uh, assume that 0 is nothing. Okay, it is off. And assume 256 is max, or 1. So in digital you have 0 and 1, but in analog you would say I have 0 and 256. So there are 256 steps in between. Okay, so there are 256 steps in between, and then you can write code which will say that if we have reached like 50, then turn the LED on very slightly. If we have reached, let's say, 100, then it is bright, comparatively brighter. If it is 128, then it means it is at exactly 50% brightness. And it is at, if it is at 256, it is at 100% brightness. Okay, so you can have kind of uh, levels in between, and these levels you can think of it as steps. Okay, think of it as like small step, more small steps, small step, up until like you reach the 256, which is the highest step. So this is your pulse width modulation. Okay, like small step, small step, small step, and you reach the highest 256, 0 to 256, and everything in between. So you can use pulse width modulation for these things. uh, Analog to digital converter, I would say, kind of does similar things, where you can read analog data and convert it to digital. What I said with LED is you take the digital data in a way and try to convert it to analog, because you're taking, like, your ESP32 is going to give you like, yep, this is how much power I'm sending. And then you have kind of a controller in between which will decide, okay, uh, this much power minus this much kind of voltage converts to this much of electricity. Let me just power it just this at this point. Okay, so that 0 is no power received, 128 is power received, but we need to kind of segment it or resist too much of voltage or current coming in. 256 is do not do any resistance, just let everything flow through. So that is kind of going into a digital to analog way. But you can also do analog to digital, where your system can actually read values which are analog and try and convert them to digital. Example, when I was talking about the brightness, like you want to water plants based on the amount of brightness that you are getting. Okay, so you can read the voltage from a light sensor, where the light sensor, depending on how much light is falling on it, can kind of give you a digital value to it. You can also have digital to analog, right? So analog to digital, digital to analog, pulse width modulation. I think these are a few terms, and I don't have a write up for it yet. My notes are very messy, so I will try and create some notes which are more understandable. I'll try to add some more links to it so that you can just go through it. And all of it would be available on my GitHub repository, though I've not shared it yet. So don't worry, I will share it as the time goes. Okay, I think that is exactly an hour of me talking about ESP32 pins. Okay, now the most interesting bit of this conversation is that I am not going to use any pin for any sensor. Yeah, all I'm going to do is connect to it via the main connection wire that I have here with my ESP32, which will send it power as well as will use it to send data to ESP32. That is one thing. We'll use it to connect with Wi-Fi. That is the other thing, and that's it. Okay, so I'm not going to connect any sensors. This was just for your understanding slash kind of an explanation. Now, the next part is going to focus on things that I did to install ESP32 on my system. Okay, now this bit I am going to actually da, 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 make notes about, so you can also follow along. I am going to start by logging in to my GitHub account. Okay, and I'll create a repository. Two-factor authentication, of course. Who doesn't love two-factor authentication? Okay, hopefully all of that made sense. Thank you so much. I really appreciate this. Okay, cool. Yeah, as I was saying, hopefully all of that, not all of it. I'm not assuming slash I'm not expecting in general like you need to understand all of it, but at least some of it made sense. Okay, I hope some of it made sense. I am going to make this repo be called ESP32 GHW. I'd say we are in 2026 session, like season 26. Okay, so ESP32. Oh, let me put it right here. Okay, ESP32 GHW26. It is public, and yes, add a README and create repository. Good. That is done. I am going to clone this on my local. So let me actually clone it one step outside of this. And let me also close this one. Okay, I'm going to clone it right here. So git clone, and this one, that should clone it. Perfect. And I'm now going to open it in Visual Studio Code, which should be quick enough. Nope, wrong place. This is ESP32 GHW26. Clear and open it. Okay, perfect. And let me just zoom in a bit and close this. And there is one readme right here. Perfect. And what else? Let me just improve this one. ESP32 GHW API weak. Cool. Ah, 32, not 31. Sorry. uh, okay, cool. So this is the reason why I'm doing this is I want to see if my Git is currently set up with the correct user. I have two users and I need to keep switching between them. Okay. Okay. Git add, git commit. This is a chore update readme. As I thought. Yep. That is the wrong user. I'll need to move the screen away so that I don't get doxed about my email. Perfect, done. Okay, so that's done. Update readme, and hopefully that is now gone with the right user. Yep. Two commits, both of them are about the readme. Okay, cool. So now this is a public repository. So everything that I do from this point onwards will be available on my GitHub repository. So you all can open it and keep an eye on it as we move along this 4-part session. Everything that I do will be available on GitHub. Okay, cool. What's the next bit that I want to do? Let me, excuse me. Okay, so the next bit that I want to talk about is what did I do, the steps I took to install ESP-32 on my system. Okay, now the steps would be simple, but it's just a lot of things. Let's just say that yeah, it took a bit of time, especially like I kind of messed up in the middle of it, so I had to kind of restart from scratch, and I hope you don't make the same mistakes. Cool. So things that we are going to use. Okay, uh, we are going to use Visual Studio Code. As you can see, that is my favorite IDE or code editor, but one of the popular ones is called Thorny Python. So this is also a very popular one, popular IDE that you can use to run things. It's popular, but I did not go for popular. I went for something that I am more used to, which is Visual Studio Code. So I did all the setup in Visual Studio Code. The next thing is we are going to use a library called as ESP tool, or this will be used for flashing the ESP32. So Python libraries and PyPy ESP tool. Okay. So this is a library that we will install on our system to basically use for flashing. Then we are going to install MicroPython firmware. Uh, so MicroPython And finally, we'll install a few drivers. Okay, uh, they will come from Espressif. Let me open that link. I definitely have it saved somewhere. Okay, cool. So these are a few things that we are going to install and add to our, add on our system. We'll write some code to use them, and yeah, we'll take it from there. Cool. So step one, let's talk about things to install. Let me open. I made a note of things that I did, then things that I messed up, then I deleted them, then I like wrote it again. Okay, so I had to do this couple of times basically. Uh, okay, cool. So let's start with the first bit, and let me start by creating a virtual environment. So the assumption at this point is that you have Python installed on your system. I have Python 3.12.4 or 3.12.4, depends on how you read it. This is what I have installed on my system, and you can install it by going to download Python. Okay, so you can install it on your system by visiting their official website, download website. There you go. As I said, things are going to be very basic, very beginner level. You might get bored, but I would say please stick around to help others. Okay, so even if you know these things, stick around to help others who might not. Okay, that's all I can say, or all I can request. Okay, cool. So no questions, anyone? And okay, cool. So the next thing that hopefully you have it installed, you can download the latest version. I think I'm happy with the one that I have on my system. So that is good to go. Slightly, yep, right here. Cool. The next thing is I'm going to create a Python virtual environment. What is a virtual environment? So think of virtual environment is as what do you call, a box. Okay, so your whole system, your whole laptop is a bigger box. Okay, it's your system, your global system. As if I have to say, then I'll say that it is your global system. Okay, your laptop, your computer, your desktop, whatever. And then if you install a library, example Python. Okay, not library, you install a tool, then it is installed globally on your system. Okay, at the parent level, the topmost level, if I have to say. Okay, so that is like a global thing, or install things are installed at a global level. But you can also have things which are more local. Okay, and when I say local, I mean that they exist in this smaller environment. Excuse me. They exist in these smaller environments, and they can be used only in that smaller environment. And what it will help is that if you have multiple of these smaller environments, they won't clash with each other. So in Python, you can do that by kind of doing something called as a virtual environment. Okay, you'll create a virtual environment which is a smaller box which will have its own Python. You can install a bunch of libraries, and all these libraries, they are going to help you like basically write code. But if you install, let's say, version version. What is the version of ESP tool right now? Yeah, okay. Let's say you install version 5.1.0 in this particular virtual environment, and you want to create uh, another virtual environment, which will be which should use 4.9.0. Then if you install it in this virtual environment, then you won't have to uninstall the previous one and install the new one. Okay, all you can do is basically focus on okay, like this is what I want in this particular environment, and this is what I want in uh, this other particular environment, and it should take care of everything. Okay, right there. Cool. So virtual environments, they are these smaller environments that you will use to ensure like none of the things are clashing. Now, uh, that's about virtual environment. So let's quickly create a virtual environment. Do, 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 do. Okay, so I'm going to create a virtual environment using Python 3-m venv, and I'm going to call it ESP-env. Okay, that is the first thing that I'm going to do. So this creates a folder called as ESP-env, and it has a bunch of things. It has Python 3 installed. Excuse me. It installs a bunch of things, and also I'm not going to push this, so I'm going to go create a .git ignore, and I'm going to say .ds underscore store uh, yeah, VS Code folder and ESP-env. So these should not be pushed on GitHub. uh, what else do I not want on GitHub? Let me see. I'll create a util folder as well, a utils folder, let's say. PyCache folder also is not needed. PYC is not needed. If you open this on IDEA, that's not needed. ENV is not needed. Log is not needed. And yep, all these I think. And then .ipy notebook checkpoint slash. So these things, ds store, I think that is correct. I think that is correct. Okay, cool. So when I say not needed, so when I do push, okay, when I push things on GitHub, I don't want this ESP-env folder to be pushed. So step one, I'm going to say is, oops, set up Python virtual environment. Nice. I like what it does. But this is not the command that I ran. I ran ESP-env, right? That is the command that I ran. Python 3-m venv ESP-env, and then the like that creates the virtual environment. And now I also need to activate it. Notice this one, it says base right here for me, but now once I run this particular bit, it says ESP-env, which means if I now do Python dash dash version, it should tell me some version. Actually, which Python should tell me where it is coming from. It is coming from this particular folder. Okay, ESP-env bin Python. Cool. So nice. I like this. But this is for Mac OS or Mac/Linux. And for Windows, I don't think this will work. So, okay, cool. I'm going to leave it at this, but I'll need to basically Google this bit. Activate Python venv Windows. Okay, so dot venv slash act. I think this should work then. Oh, dot scripts slash activate. Okay, so the dot means that you are in this particular folder, and inside go inside the ESP-ENV folder, which is what we have created. Go inside the scripts folder that should be created on Windows when you run this particular command. This is, wait, there will be a separate one for Windows. Okay, cool. Not sure if that is correct. And then you will go, you'll run this activate. So just two dots, and then yeah, go inside the correct folder. You have to go inside the scripts folder and run the activate. I don't know why it thinks there's a difference between Python 3 and Python. I think Python 3 should work on Windows as well. Okay, let me see the chat. Perfect. Thank you so much. Thank you so much. And thank you so much. Thank you for someone who's sticking around and helping answer questions in the chat very quickly. Really appreciate that. Okay, cool. So that's us in like kind of activating the virtual environment. So I have activated the ESP-ENV virtual environment that I've created. Now, the next bits are going to install a bunch of libraries in our ESP-ENV virtual environment. The first one that we are going to install is going to be, or actually, before we do any of those, let me quickly upgrade the Python package installer. So I'm going to do Python 3 space dash m, and then I'm going to do pip install dash dash upgrade. Okay, perfect. This is going to, I mean, Python 3 and Python. I think Python should work. I don't really need Python 3. If I can just remove that. Yep, it works. Cool. Okay. Cool. I have no idea why it keeps going to that requirements txt. I'll ignore that for the time being. Okay, the next things that we need to install on this is, wait, let me see which PIP it is at the correct ESP-ENV bin pip. Cool. Okay, the next libs that we need to install are, nope, not this. Sorry. Pip install. We are going to install ESP tool. We are going to pip install MP remote, and that's it. Cool. So what are we installing? ESP tool. ESP tool, as I said, it will help us kind of, it's a command line utility which will allow us to upload or communicate with the ESP-32 bootloader, or think of it as communicate with the ESP-32 CPU. Okay, and we can upload some sort of firmware on it. So upload some sort of operating system on it. Okay, I'm kind of generalizing, but I think these words would make much more sense in terms of understanding. Okay, so what I'm doing is I am installing ESP tool, sorry, which will help me communicate with ESP32, ESP32's system, and then I can upload some sort of firmware, or think of it as operating system on it. I can upload, like, let's say, think of it. Okay, I'm not uploading this, or I'm not doing this. This is not exactly what it would actually do, but to understand, think of it as being able to communicate with the microcontroller and upload windows to it. Okay, so that is ESP tool. And then once it is installed, you can actually communicate with it by using version. I think this should work out. Yep. So this is the version it installed. It says that esp-tool.py is deprecated. You can just use the esp tool word. So I think if I remove this bit, it should still work. Perfect. Cool. So this is what we have done. We have installed it correctly. This is one way to confirm that you have installed it correctly. Cool. Next one is going to be MP remote. Okay, so what is MP remote? So that is a tool which will allow us to communicate or install things. MP remote, if I can quickly search it here. Hmm. So this is going to, it's a CLI tool which has a set of utilities which will allow us to communicate with a MicroPython device, okay, over a serial connection. Remember the whole serial, I2C, UART, all those words that I was throwing around? This is where it comes helpful. Okay, now what is MicroPython? So MicroPython, as the word says, it is a lightweight version of Python. Okay, it is MicroPython is a lean and efficient implementation of Python 3 programming language that includes a small subset of the Python standard library, and it is optimized to run on microcontrollers. Okay, I think all of these words will make sense, right? In Python 3, we installed Python, and MicroPython is a smaller version of Python. Okay, it is optimized language, which means like if Python is, let's say if it is 300 MB, MicroPython would be 3 MB. It's not, but generalization wise. Why? Because it does not implement everything that comes with Python. It only takes a small subset of it. It goes like, okay, to run like these smallish or smallest things, which is what you would do on ESP32, like microcontroller. We only need these pre-installed libraries, and so MicroPython is built from that perspective. And you don't need to like so normally if you are writing code for microcontrollers, you would use C or C++, things like that, okay, which you need to first compile so that it becomes these smaller bits, and then you will actually install it on like you'll send it over to your ESP32, and then you'll add commands to run it, and it would be a faster uh, code, but it is very unfamiliar. It also very cumbersome. So instead, we'll use Python because we all know Python. Uh, that's the assumption that I have. And also because it's easier to read. Okay, understanding Python is comparatively easier. So you don't need to, and also you don't need to compile your code. You can just literally copy paste the code file from your system over to ESP32 and just run it. And it has like MicroPython has like built-in GPIO libraries, Wi-Fi libraries, sensor libraries, machine libraries, so you can communicate, like understand what is your ESP32's memory, CPU, stuff like that. Okay, so hardware stuff, fastware stuff, like everything is kind of good. Performance wise, as I said, it is not as good as writing in C or C++. And it uses more memory because it is not compiled. Okay, uh, but if you write code in C or C++ and you upload it on ESP32, then you'll have a faster code. You'll have things which be more performant. Okay, but we are going for easy, not fast, not optimized in this case. Okay, also I think C++ syntax is very hard to learn. I've tried learning it. I've tried understanding C uh, in a better way, but I still struggle. Okay, cool. So that is MicroPython, and to communicate with a board which runs on MicroPython, we will use this MP remote, or MicroPython remote control library. So let's install that very quickly. Oh, I have not installed even this. No, I installed this one. Let's install this one. Pip install MP remote, and there we go. It has installed it successfully. Cool. Okay. And finally, the next most important thing that you will need on your system is this, the USB drivers. Okay. So what is this? So USB drivers, these are, like, let's say, pieces of code that run on your system, and on your system is on your laptop, on your computer, and they allow you to communicate with devices. Example, there will be a driver installed for communicating with microphone. There will be a driver installed for communicating with camera on your system. There will be a driver for communicating with speakers. So in this case, we need a driver that will allow communicating with the ESP32's USB, uh, USB, yeah, in a way USB. So my system needs to talk to USB, ESP32. I need my system to upload code to ESP32. I need to send live uh, code or commands from my system over to ESP32, and for that I need a driver, and this is what you will need. So I have shared this link. So let me add it to the README again. I've nope. Install uh, 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 USB drivers. Ooh, nice. But this should be Windows/Mac. Okay. And I have no idea what that is saying. So I'm going to quickly put this link, and let me also add this text here. Okay, cool. So if you go over to this downloads page, then here you have a list of the drivers. Uh, on my system, I of course install this Mac OS X one. You can install the Universal Windows driver, or if you have a Windows machine, or you can install this one for Mac. I am not sure if there is anything specific for Linux. I'm assuming it just works. Uh, a Linux system, again, a presumption is that it just works. Cool. So 210X. Okay, so this is CP210X. It is from Silicon Labs, and it like, I would say, ESP32 boards like Node MCU and other ESP32 boards, they have, like, they'll need this. But if you have something like CH340 chip, then in that case you'll need it from WCH. Let me try and find that one. I think it's this one. So you can have like other cheaper versions of ESP32, right? So depending on the chip that they are using, you will need something different to detect the board. Okay, like where can you communicate with your ESP32 via your system? Okay, on which port, or under which name. So this 210 0, this is I think the most common one. And you can use this driver to communicate with your ESP32. The 341, if you have something which is even cheaper than £1, ESP32 boards or ESP boards that are cheaper than £1, you could technically, like not technically, you'll need to, depending on the chipset it uses, you will need to download some other drivers. So you can go into this driver, and I think the CHP340 drivers, and oh, it's not showing anything interesting. Da-da-da-da-da. I'm pretty sure one of these. Okay, very weird. I'll try and find the link, but again, totally depends on if you actually need it, like depending on the chipset that you have. Okay, cool. So that is one thing. So I have installed that already on my system, so I am good to go. It won't be visually there. There's nothing to see visually, but once you have connected your uh, USB port to your ESP32, after that, we will have a bunch of commands to check if you are actually able to communicate with ESP32, or if you are able to actually kind of talk to it and see it is installed or not. Okay, so after installation, make sure install USB drivers, restart your system after installation. Yep, perfect. Now, next one is, I have no idea what this means, but I'm going to just select it. And I'm also going to say that this is AI generated content. Cool. This one I'm sure, because, well, I have followed these exact steps. I'm not sure about this one. Cool. Uh, check connection. Okay. Uh, so to check the connection, yep, I have, nope, 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 no. This is not what I did. So what I did was this. ls/dev/cu dot star, and this is for Mac OS or Linux. Okay, and this is for Windows. Okay, I am going to keep saying that this is AI generated, because I am not able to verify this. So I think uh, my request for anyone who has a Windows system, has access to ESP32, please, please, please try it out using these exact commands, and then let me know that whether it works or not. Cool. Okay. Let me try it out. Okay, so what does this command do, and what it is, like, it's going, what is it going to show? So it is going to detect all the devices. So think of the /dev as the devices, and we are doing cu, which is like calling out all the devices which we can talk to using USB. Okay, cool. And let me. Okay, so there's currently nothing found, which is interesting. Cool. I guess we'll need to first try and see if it is working. Is my ESP32 working? I think it should be working. It was working right before the session for sure. Oh, uh, there's a mistake that I made. Yep, I forgot a forward slash. Yeah, there we go. Perfect. So I can actually copy paste this, and I will say all underscore devices dot txt. Okay, so I've created this all devices dot txt, and here we go. So what it is doing is it is telling me that you can actually talk to this Bluetooth incoming port. There is this debug console. I can also talk to this OnePlus Bullets Wireless Z, which is not a earphone that I own anymore. There is this SLAB USB to UART for Silicon Labs USB to UART, and I have this USB serial 0001 and this WLAN debug. So these are all the devices, or all the yeah, I would say devices that I can kind of talk to serially. One of them is connected, which is this one. Okay, so this should, the output example would be something like this. Okay, and this one is actually our ESP32 device. So now I'm not going to share all the devices that I can talk to, but okay, I think this should be good enough. So these are all the devices that I can talk to, and I know that this is my ESP32 device. How do I know this? Actually, let me show you how do I know that. If I remove ESP32 from my system, I have disconnected it, and let me, before ESP, so if I print that out, these are the four things that I can talk to. And now let me connect it back. So proof of that I have disconnected. It is not lit up. Let me show it on. Okay, it is not lit up. And here we go. So it is disconnected. And that is exactly when it shows like these are the ones that are currently I can talk to. Now, if I do, like if I connect it, oof, I have connected it. It is lit up. And now I try to go for after underscore esp.txt. So this is me taking the output and printing it inside this txt file uh, after. So all I need is a diff between before ESP and after ESP, right? And the only difference that I can see is actually these two. Okay, there are these two things that are different between the before and after. So I can do a diff of before underscore esp.text and after underscore esp.text, and it says that there are these two things that are different between these two files. Okay, so that's one way to know that the additional thing that starts running on your system is these two. And from that, after a bit of back and forth, I realized, oh, not a bit, just one line. I realized, oh, actually, this USB serial 0001 is my ESP32. Cool. So I will actually copy paste all of this. Hmm, don't need this, don't need this, then this, and it will return some output, and don't need this, and don't need this bit. This is nice. I like it. Perfect. So this is good. So this is before plugging in ESP32, list devices after plugging in, compare the two lists, and this is the difference. Okay, this is the output. And I am going to just remove these three lines, put this here, and put double forward slashes. Oops. Okay, perfect. So this is what I have done so far. And now you can see, I can actually remove all devices. Also, before ESP, just going to remove this bit. Doesn't actually matter. All you will know is I used to own a pair of OnePlus Bullets wireless C. Okay, cool. So these are the things that I ran and output examples. And I will say that this is our ESP32 device. So perfect, cool. The commands we ran and the output. And this is our ESP32 device. Cool. Okay, so all this to basically check that which is the device I am going to communicate with via my system. Okay. Next bit is I am going to flash MicroPython firmware. What does it say? It says this, but okay. Let me see if it is. Step one, we don't need the .py bit, so that's fine. Let's remove that. And I'm going to remove, actually just keep it at this point. Okay, cool. So erasing the flash, this is basically, imagine or think of it in a way that this is where you uninstall the previous operating system. You are deleting the previous operating system. You are deleting everything that it had before, and you are starting fresh. Okay, let me add a note here. Okay, this is one note, but also the other note that I actually wanted to add was replace perfect. Nice. Can I put a danger symbol? How do I get? Come on. Finally. Warn. Okay, that didn't work. At least not the way I wanted it to work. Okay, cool. This is one, and this is the danger bit. Okay. Okay. So this bit can go inside this bash command. Step one, we are going to erase everything. So let's do that. And I'm going to run this and ESP, oh, erase dash flash instead. Okay. So even this is wrong. Nice. I did not notice that bit. Let me run this and there we go. Perfect. So this is the output that I got, and I am going to add a sample output. So the command that we ran, it's this one, and the output it gave us is this particular bit. Oh, so I have Wi-Fi, Bluetooth, dual core plus LP core, 240 megahertz, VREF calibration in eFuse, coding scheme none. Nice. My crystal is frequency is 40 megahertz, and it has my MAC address as well. My MAC address or the device MAC address? That's interesting. Stub flasher running. There was a space in between these two. So the reason why I'm also adding a sample output is when you actually run this command on your system, you should have some sort of idea of what you can expect. Okay. I'm going to reduce the number of spaces that I have here. Okay, cool. So I'm adding all the sample outputs. This is the command and this is the sample output of that one. So we have erased everything from the ESP. Next is we are now going to update the ESP and we are going to install the uh, MicroPython framework that we have. Okay, cool. Where did I get that and where did I install it from? That is another thing. So I installed it. Let me go and find the URL quickly for you all. If I go to ESP and if I go into the downloads, if I search for ESP32, yep, this is the one. Yep, perfect. So I am going to I had to download the ESP32 from here. So yeah, here we go. Perfect. So I downloaded this bin file from here. So let me share this link with you all on the chat. Okay. Cool. So theoretically, all I did was actually run this thing. Okay. To uh, repl- basically install MicroPython on ESP32. So this one, I think it's supposed to be some X number of KBs, only 48 or 480 KBs or something like that. I'm not sure. But this is like installing Python on your system. So if you download Python on your system and you install it, that is what we are doing by downloading this .bin file. This is the one that I downloaded. And then we are once you save it, then you can basically just what do you call run it. Let me quickly create the utils folder. which should not be pushed, and I am going to reveal it in Finder. And since I've already downloaded it, I'm not going to download it again. But this is what I had downloaded: ESP32 generic and 1.26.1, which is this one. Okay, 1.26.1. So this is the .bin file that I had downloaded. Uh, so important, from the options below, download the .bin file for your board. I downloaded the first one and it worked, so that was good. And all the commands that I wrote was from here, and that's why I had erase underscore flash, but that is no longer the case. It is erase dash flash. Okay, so that, and then now this is the flashing bit, or installing MicroPython on the board. So let's quickly do that. Okay, I hope you all got the link of where to download it from. Okay, download the bin .bin file and save it somewhere. In my case, I'm saving it inside the utils folder. So I am going to cd into the utils folder, and I'm not going to push it to uh, not going to push it on GitHub. I am going to say that note download the latest firmware from this particular link. Okay, I went for the generic one, and in bracket the .bin file from this one, and I'm going to say in this example I actually downloaded this particular. We use this. Okay, cool. In this example we use this particular bin file, and what else? I think this should be good enough. So I think this has all the details, right? So download the latest firmware, which is the .bin file, from this URL. And in this example, this is the one that we use. And let me copy this thing. I know ESP tool.py is deprecated, so I'm going to remove that. So that's good. Like, it's good, like if you read the messages, right? Next, I don't think this is the right command that I ran. I definitely ran a bit of a different command. Okay, so let me write the command that I ran, and then we can see. Yep, kind of this one. Let me read it. Is this the correct? Yep, that is the correct one. ESP32, the port name, of course, that is needed. Then the baud rate. Okay, write flash dash z 0x0 and the correct bin file. I think that's it. Let me see if there is anything else that I had done. Excuse me. Okay, let me replace the file name with the one you downloaded, and in this example we use this one. Okay, ESP tool is fine, and oh, the port. Replace dash dash port value with your device path. Okay, cool. So what do we have here? ESP tool, that is the library that we downloaded for flashing this out. The chip basically means the target device, and we are saying that it is a ESP32 device. The port is where we have connected our device, so that is fine. The board is basically to tell it that you use a faster rate of transfer of data. So it is, think of it as how faster should it flash the device. Okay, speed of flashing. And the write flash is and dash Z0x1000. It is basically a way of saying that please upload this data to this particular memory address. Okay, and this is what is a standard for ESP32. Here we go. Okay, and what else? The firmware to upload, of course, that is what we have written. I think this underscore will also change to dash, considering that erase underscore flash changed to erase dash flash. I presume, excuse me, I presume even this would change, but let's first run this, see what happens, and then we can take it from there. And let me clear this. I am inside the utils folder because uh, that's where I have this file. Okay. But if you want to do it from one step before, then you'll need to say that it is in dot slash utils forward slash this file. Okay. You need to give it the path. Let's hit enter. Yep, as I thought. This is deprecated. Use the write flash instead. So write dash flash. So we can write it again. So we can do the whole erasing bit again, and we can do the writing bit again. Uh, there we go. It took 30 seconds and that's done. Uh, so just so that we have the right commands and I can copy paste the right output, I am going to erase the flash again and quickly run it again. Okay, what's the time? I have 4 minutes towards the end of this session. So before we end it, let me just do the right flash bit again. Perfect. And okay, nice. Good, 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 good. Takes around what, 30 seconds? It took 30 seconds last time. It takes 6.2 seconds to erase everything. It takes 30 seconds to write everything. Nice. Not bad, I would say. The speed of flashing is quite fast, like quite good. Wow, it takes exactly 30 seconds every time. That's cool. Okay, let me copy this over and let me say sample output. Wow, it now knows. I like the way it understands the generic bits. Cool. I think this is good towards the end of the first session. So we have flashed it. Uh, we have flashed this USB 32 and we have installed MicroPython on our system. And finally, before the end of this session, one last thing that I want to do is basically see if I can actually run MicroPython on my system, right? So I am going to use the MP remote, if you remember, MP remote, and I'm going to say connect to this USB device. Okay, and start the REPL, which is interactive way of writing Python code. Okay, so read, evaluate, print. I forgot what the L stands for. List. I don't know. But okay, so this is trying to do something, and wow, that is a lot of things. But anyways, I did Control C, and now I can say print hi, and it returns hi. Print hello from ESP-32, and it returns this. Okay, and where am I running all of this? This is actually being run inside the ESP-32. Okay, so now I can do Control A and Control B to exit. Nope. I wonder. Come on. Try to remember. Try to remember. I think it is Control A, K, Y, Control X. No. Yeah, Control X. Control X to exit. So, verify installation by connecting to REPL. Yep, this is what we did. And this, and you can now try on this bit. This is Python code inside of, oops, nope, not this one. This will go right above this thing. And what did we do? I did print, and this should return the output. This one, and that's it. Perfect. So this is currently what we have. Okay, so I can quickly do it again. So the first time it will do a lot of things, but you can do Control X to exit this shell, or Control C. Oops, I don't like this bit. Okay, anyways. Okay, so this is the end of first session. Let me come back on screen. So what have we done so far? We have not done much in terms of the actual coding bit. We have done a lot of installation stuff, and I've written down the notes of everything that I ran step by step so that you can do it. And I am going to come back one step, and I'm going to say get status. So it has get ignore us after esp.txt, before esp.txt, and I think that's all of it. Cool. And I am going to push this. So I'm going to say git add all, git commit, and this is session 1 installation. And I'm going to push this so that this will be available on your GitHub. My session 2 will start soon. So let me give you like 15 minutes break, and you can come back after 15 minutes. I'll post a message on the Discord chat so that you don't forget to come back. And yeah, I think that's good. Any questions, anyone? So we have done this installation bit. I have ensured that everything that I do has been kind of covered in my details. I should improve this bit. Okay, I will do that during the break. And yeah, that's it. And finally, before you all log off, I have a very quick request. Please fill a feedback form. So tell me, like, what did you like about this particular session? What you didn't like about this particular session? So you can, it will take 5 minutes to fill this, like maximum 5 minutes. This one was the ESP-32 part 1 session. So you can rate it. I'm not going to rate myself, of course, but rate it. Tell me what you liked, what you didn't like, and based on your feedback, I can improve next time. And please, yes, please do provide feedback. And what else? Yeah, let's take a 15-minute quick break, and let's come back after the break and continue of what we were continue with what we were doing. The GitHub is already in the chat, and I will share an announcement on Discord. I'll start the stream like in like next 5 minutes, but you don't have to join. Take your time, take a break, and then come back. One last time, any questions, anyone? Or is it good to finish at this note? For me, the time is 14:05, so we will come back at 14:20. Okay, cool. I'm going to take the silence as golden. Thank you so much, everyone, and see you in 15 minutes for the next part. I'll start the session, but you don't have to join. Okay, cool. Thanks all. Cheers. Bye.